All right, welcome, sixth period. I'm out today. My daughter is sick, so I'm at home right now. I'm here with my fifth period class. They're awesome. Y'all are awesome too. But 8.4, congruence and proportions in similar triangles. That's what we're learning about. You should have these notes already. Let's talk about this. Once we know two triangles are similar, we can use the definition of similar polygons to prove that corresponding sides of the triangles are proportional and corresponding angles of the triangles are congruent. So here we have two triangles, triangle ABC on the left, triangle DEF on the right. We actually don't even need those two triangles. If we just had that congruency, or the similarity statement, be careful about that. We're talking about similarity, not congruence. If we had that similarity statement, we already know a bunch of stuff about these two triangles. We know that angle A is congruent to angle D. Okay? And I am just using one letter because we do have the figures, and so I know that I can call it angle A, I can call it angle D. We also know a couple other things. We know that angle B is congruent to angle E. Angle B congruent to angle E. And then finally, angle C is congruent to angle F. Angle C is congruent to angle F. So the corresponding angles are congruent. The corresponding sides are not congruent necessarily. They could be, but they are definitely proportional. So AB, that's first and second. What does it correspond to? DE, first and second. So AB over DE is equal to, all right, let's keep going here. So I did triangle on the left over triangle on the right, so I got to keep going that way. You could have gone triangle on the right over triangle on the left, but however you start, you got to finish that way. BC is second and third over EF is second and third. And then finally, what's the last one in the numerator? AC, first and third, over DF, first and third. Oh, that's a bad F. There we go. All right, so there you go. That's the information we can conclude from that similarity statement. Example 2. Try this one on your own. Be careful. Find the values of x and y. I'm going to pause the video now. Pause the video now, please, on your own. If you need a little clue, in a minute or two, unpause it and take a look. Good luck. All right, here is your hint. These two angles are congruent to each other, and because they're alternate interior angles, and these two angles are congruent to each other because they are alternate interior angles. Angle lets you know these two triangles are similar to each other. You can then set up your proportion using corresponding parts. So finish that if you've not. All right, let's take a look here. So 6 is between the 2 tick mark angle and the vertical angle. So it corresponds to what? Yeah, 6 and y are corresponding. So we'll say 6 over y is equal to, all right, so I did left over right, left triangle over right triangle. 8 is the side between the 1 tick mark angle and the vertical angle. That corresponds to x. X is the side between the 1 tick mark angle and the vertical angle. So we're going to say 8 over x, stick with that left over right. And then finally, 9 is the side between the 2 tick mark angle and the 1 tick mark angle. So is 15. So again, left over right, that is 9 over 15. Now to make our lives a little bit simpler, I'm going to say 9 over 15 is equal to, well, we can divide both these by 3, and we get 3/5. So 3/5 or 5/3, or you could say 3 to 5 or 5 to 3. That is our similarity ratio, right? Similarity ratio. So I'm going to use that simplified similarity ratio just to make the multiplication a bit easier. So 6 to y, that is left to right, is equal to left to right 3 to 5. Okay? We cross multiply and solve. We get 3y equals 30. Y has to equal 10. Let's do the same thing with x. 8 over x, that is left over right, 8 over x. And so left over right, that'd be 9 over 15, but we simplified it at 3 to 5. 8 times 5, we get 40. X times 3, we get 3x. So 3x equals 40, divide both sides by 3, and we get x equals 40 thirds, which is the same thing as 13 and a third. So there's x, 40 thirds. Now let me show you another way to do this. I don't want to call it simpler, but you might consider it simpler. 3 to 5, that's our similarity ratio, right? If we're going to go from 8, and 8 corresponded to what we said? What did 8? X. All right, are we going from bigger down to smaller, or smaller up to bigger? In other words, are we going to make 8 bigger, or are we going to make 8 smaller? We're going to make it bigger, right? How do you know that? Well, 9 corresponds to 15. So if we're going from 9 to 15, we got to make 9 bigger. So I'm going to say 8 multiplied by, now my similarity ratio is 3 to 5. If I multiply by 3/5, is 8 going to get smaller or bigger? Smaller, right? Think about when you multiply by 1/2. When you multiply by 1/2, like 100 times 1/2, that's 50, right? It gets smaller. So 8 multiplied by, we got to flip that similarity ratio, 5 thirds, and we end up with 40 over 3. That's equal to x, right? Let's do the same thing with y. 6 and y, they correspond to each other. So 6 multiplied by, all right, if I'm going to go from 6 to y, do I have to make the 6 bigger or make the 6 smaller? Remember, 9 bigger, right? 9 to 15, if we're going from 9 to 15, the 9 has to get bigger to become 15. 6 to y, 6 is going to have to get bigger to get to y. So 6 times, again, we're going to multiply by 5 thirds because that's our similarity ratio that's going to make that 6 get bigger. 6 times 5 is 30. 30 divided by 3, we get 10 equals y. So that's a little bit shorter, right? The similarity ratio can help you. You don't have to do it this way, but it's good to know it just in case, all right? All right, so we have 2 different ways to work that problem. I'm okay with either. Just make sure you support your work, whatever you do. Take a look at example 3. We got this side parallel to this side. How do we know that these 2 angles are congruent to each other? Raise your hand if you know. Grace? Yeah, they're corresponding angles. Very good. And then how about these 2 angles? Back up. Also corresponding. And then what's happening up here at this vertex angle? Well, the reflexive property, right? So 12 is between the shared angle and the 1 tick mark angle. So on the bigger triangle, the shared angle and the 1 tick mark angle is a length of 20. So 12 corresponds to 20. What does 16 correspond to? Sixteen corresponds to, well, 16 is between the shared angle and the 2 tick mark angle. So between the shared angle and the 2 tick mark angle, that's going to be 16 plus x. So set up, well, when you're dealing with 16 plus x, set up a proportion. I don't care how you find y, but when you're finding x, make sure you set up a proportion. Don't use that new method I showed you, and we'll talk about y in a bit. But all right, good luck. Pause the video now. Give that one a shot on your own. You're fine. So 12 to 20. 12 corresponds to 20, right? That simplifies to 3 to 5. That's our similarity ratio. So what we can do, we can take 22. All right, if we're going from 22 to y, are we trying to make 22 smaller or bigger? Well, 22 corresponds to 20. Y corresponds, I should say, excuse me, back up. 22 corresponds to y. 20 corresponds to 12. 22 is in the larger triangle. So we're going from the larger triangle down to the smaller triangle. So we've got to make 22 smaller. 22 multiplied by your similarity ratio of 3/5 gives you 66/5, which is 13 1/5, or 13.2. Okay? So that's that new method. Now the old method, which actually works out a little bit better for what we're doing with x here, 16 corresponds to 16 plus x. And then we already talked about our similarity ratio of 3 to 5, right? That's 12 to 20. So small to big is equal to small to big. We cross multiply here. What's 16 times 5? 80. And then what do we have to do with this 3 and the 16 plus x? Something special. Yeah, the distributive property. So 3 times 16 plus x. I'm okay if you skip this step and you jump straight to what's next. 3 times 16, that's 48. Plus 3 times x, that's 3x. So if you jump straight to here, that's okay by me. So we cross multiplied. Make sure you use the distributive property. Subtract 48 from both sides, and we get 32 is equal to 3x. And so x has to equal 32 thirds. Or what is that, 10 and 2/3? 10 and 2/3. There you go. Questions on that? The hard part here, a couple things. One, realizing that 16 corresponds to 16 plus x. A lot of people try to say 16 corresponds to x. Don't do that. 16 corresponds to this entire side, which is 16 plus x. We got to use that distributive property when we cross multiply there. Okay. Okay, example 4. This is a very common similar triangles problem. It shows up on the SAT often, so this is something that would be good to commit to memory because it's a pretty straightforward problem type, and it's not too bad. A person who's 5 feet 3 inches tall, and here you can see it's already been adjusted for you to 5.25 feet. You always want to be in the same unit. You don't want to be in feet and inches. It just makes your life a whole lot easier. So 5 feet 3 inches is 5.25 feet, 5 1/4 feet. When you stand upright, hopefully you're perpendicular to the ground. Hopefully you're not leaning or whatever. Okay. A lamppost, if it was installed correctly, should also be perpendicular to the ground as well. So we end up with a right triangle and a right triangle. So let's read the rest of the problem. A person 5 feet 3 inches tall casts a 6-foot shadow. So there you see their shadow, 6 feet. At the same time of day, a lamppost casts an 18-foot shadow. 18-foot shadow. Why is it important that it's the same time of day? What about the sun, Casey? Moves throughout the day. So at the same time of day, the angle at which the sun is hitting you is the same as the angle that it hits the lamppost. At 2 o'clock in the afternoon, the sun is hitting me at the exact same angle that it's hitting the buildings or whatever. Okay, so this angle is congruent to that angle. So we end up with these two triangles that are similar by angle. So now that we have our two similar triangles, use the two similar triangles to set up a proportion and solve for the height of the lamppost. All right, well, the shadow to the shadows are corresponding. So I did 6 to 18. You could have done 18 to 6, either way, is equal to, so I did triangle on the left over triangle on the right. So that's 5.25 for the height of the man over x for the height of the lamppost. So you should have that. We now cross multiply and solve. 6 times x is 6x equals 18 times 5.25. Help me out. What was that? Anybody do that one? 94.5. We divide both sides by 6, and what do we get? 15.75. Let me show you an alternative method that's probably a little bit easier, actually. 6 times what is 18? 3, right? So 6 to 18. 6 to 18. That's the similarity ratio of 1 to 3. Or you might say 3 to 1. So from 5.25, do we have to make 5.25 smaller or larger to get the height of the lamppost? Larger, right? Because the shadow for the person is smaller than the shadow for the lamppost, or the lamppost shadow is larger than the person's shadow. So we're going to take the person's height, which is 5.25 feet. We're going to multiply it by our similarity ratio, which is 3 over 1. If you multiply by 1/3, it would get smaller. 5.25 times 3 is 15.75, and that is feet. Feet. I should have said feet down there earlier too. Feet. 15.75 feet is 15 feet. How many inches?
8.
3/4 of a foot. 9 inches. All right, so either one of those, 15.75 feet, or you might say 15 feet 9 inches. We have a proof. For the sake of time, we're going to do this all together. All right. If you're in 6th period and you want to pause the video now and try this on your own, that's fine. But here in class, we're running a little short on time. I talked too much about pound cake earlier. All right, it's true. All right. So AB is parallel to DE. That's given. So let's find this. AB parallel to DE. Who can tell me what we're able to conclude from that? By the way, I should add, we're trying to set up this proportion of AB over DE is equal to AC over DF. It probably means we're going to have to find two similar triangles. Becca, what do you think? Yep, angle B is congruent to angle E. Becca, how'd you know that? There you go, they're alternate interior angles. So number 2 here, alternate interior angles are congruent. Number 3, let's go back to our given information. AC is parallel to DF. What are we able to conclude from this? Max?
ACB is congruent to DFE.
Good. ACB is congruent to DFE. I'm glad you didn't call that angle C and angle F, because there's multiple angles occurring at each of those vertices. So you have to call it by the 3-letter name. ACB is congruent to angle DFE. And that again is alternate interior angles are congruent. Okay. Remember, we're trying to set up this proportion here, so what do you think we do next? Liv?
Triangle BCA is congruent or similar to triangle.
BCA is similar to, now we've been writing congruent a lot, so make sure you actually do write similar. Congruent to triangle, excuse me, EFD. Let's double check to make sure our similarity statement is good. B, is that congruent to E? Yes. C, is the angle at vertex C congruent to the angle at vertex F? Yes. A and D have to be congruent by the third angle theorem, so I like that. What was that reason on 5? Colin, what do you think? Reason on 5. How do we know those two triangles are similar? Well, look at the figure. Look right there. How do you know those two triangles are similar? It's angle, angle. And then number 6, we now know that AB over DE is going to have to be equal to AC over DF, because corresponding parts or corresponding sides of similar polygons are proportional. Okay, don't do that. All right, I'm going to keep this going in a second here, one moment. All right, so diving into example 6, I recommend you pause the video now and try it on your own. Okay, here we go on example 6. So angle B is a right angle right there. Angle M is a right angle right there. You see that in our given information. It means angle B is congruent to angle M because all right angles are congruent. Okay. Also, number 4 here. By the way, we're trying to show that BT times AN is equal to AT times MN. What this is the cross multiplication that happens after you have your proportion. So we got to show the triangles are similar. We need to set up a proportion, and we need to cross multiply to solve. So that looks like this. Number 4, we have angle BAT is congruent to angle MAN because they are vertical angles.
Do you know who Mr. Ainsberg is?
All right, and so now we have two pairs of angles, right? We have the right angles that are congruent, and we have the vertical angles that are congruent. So number 5 here, we can say triangle BAT is congruent to triangle MAN. Oh, thank you. Yep, so that is going to be angle. Similarity, yes, they should be similar, not congruent. So again, we've been writing congruent since pretty much day 1, and now we're kind of shifting to writing similar. So like my brain is just always wanting to write similar. So I'm sure some of y'all are like me. So just always pause when you're writing if they are similar. Try not to get in a rush. All right, now at the very end, let's look down here at the bottom. BT times AN is equal to MN times AT. So we need BT and AN to be either both extremes or both means. Doesn't matter which. So I'll put BT as an extreme. I'll put AN as an extreme, which means MN and AT are going to be the two means. Now be careful here. BT is in the numerator. That's from the triangle on the left, triangle BAT. And then AT is also in the numerator. That's a triangle on the right, which means MN is going to have to go in the bottom left. So BT over MN is equal to AT over AN. Corresponding sides of similar triangles are proportional. Right there, corresponding sides of similar triangles are proportional. And then BT times AN is equal to MN times AT. That's the means extremes products theorem. It's the same thing as cross multiplication, but in a proof, please write means extremes products theorem rather than cross multiplication. All right, thanks so much for your time. Hope you have a great day. And complete the homework, please.